Hi everyone and welcome to another YouTube video. In today's video we are going to be talking about the concept of dependence event. And before we move into the video properly, I have a question for us. So here is the question. Which of the following is an example of a dependence event? So option A, we have watching the TV and eating. Option B is picking some balls from a bag with replacement. Option C is robbing a bank and going to jail. And option D is not paying your power bill on time and having your power cut off. So tell me your answer in the comment section and wait to the end of the video to see if you have the right answer or not, because definitely I will be providing the answer to this question. So in today's video, we are going to be defining the concept of dependence event. We are going to be giving examples of dependence events, and I'll also be giving a mathematical formula that actually helps us to define the concept of dependence event. So without further ado, let's jump into the video properly. Two events are said to be dependent on each other if the occurrence of one of the events is going to affect the other. That is, the chance that one of these events occurring is going to affect the chance that the other event is going to occur. Let's take, for example, we have parking illegally and getting a ticket. So the fact that you are going to park your car illegally simply implies that you are going to be getting a ticket. If you don't park your car illegally, you will definitely not get a ticket. If you park your car illegally, you are going to be given a ticket. So that simply implies that the events of parking illegally and the events of getting a ticket are actually dependent on each other, since the chance that one of them is going to occur is going to affect the chance that the other one is going to occur. Let's take another example: driving a car and getting into an accident. So the chance that you are driving a car is actually going to increase the chance of you having an accident, or if you decide not to drive a car at all, you may never be in a motor car accident. So the event of driving a car and the event of getting into a motor accident are actually two dependent events. Just like we did when we were talking about the concept of independent event, I would be using an experimental approach to explain the concept of dependent event. And the experiment we are going to be using this time is still the concept of having some number of balls in a bag and trying to pick 1 or 2 or 3 balls from this bag. But this time, because we are working with dependent event, we are going to be performing our experiment without replacement. So let us assume we have a bag containing a total of 15 balls. We have 10 red balls and we have 5 blue balls. So 2 balls are picked at random. So how do we use this experiment to prove the point that we actually have dependent event? So the question says we are going to be picking 2 balls. So that means we're going to be having the first pick and we're also going to be having the second pick. So let's assume the question says what is the probability of getting a blue ball and a red ball. So our question tells us to find the probability of getting a blue ball and a red ball. So that means in our first pick, or on our first pick rather, we are going to be having a blue ball, and at the second pick we are going to be having a red ball. Please note that we have a total of 15 balls, 10 red balls and 5 blue balls. So at our first pick, we are going to be picking a blue ball. The probability of picking a blue ball is actually going to be equal to the number of blue balls we have in this bag divided by the total number of balls. And as you can see, we have 5 blue balls and we have a total of 15 balls. So the probability of picking a blue ball at the first pick is actually going to be equal to 5 divided by 15, and this gives us 1/3. When we convert this to decimal, we have our answer to be equals to 0.333, approximated to 3 decimal places. So at the second pick, the number of balls has reduced from 15 to 14. That is, the total number of balls has actually reduced from 15 to 14, and the number of blue balls has actually reduced from 5 down to 4, but the number of red balls remains the same since it has not been touched from the first pick. So the probability of picking a red ball in the second pick is going to be the number of red balls we have in our bag divided by the total number of balls. And as you can see, the number of red balls in our bag, we have that to be equal to 10 of them, and the total number of balls rather in this bag of ours is actually equals to 14 right now. So that means probability of picking a red ball at the second pick is going to be equals to 10 divided by 14, which when we break down, we have our answer to be equals to 5 divided by 7. Let us use our calculator to get the answer right here, and we have our answer to be 0.714. So the probability of picking a blue ball and a red ball is actually going to be equals to 0.333 times 0.714, and when we do the math, we have our answer to be 0.238 approximated to 3 decimal place. So the probability of getting a blue ball at the first pick and a red ball at the second pick is actually going to be equals to 0.238. So this is the basis of dependent event. So let's talk about the mathematics that we can use to guide the concept of dependent event. And for dependent events, let's say we have two events, event A and event B, where P of A is the probability that event A is going to occur and P of B is the probability that event B is actually going to occur. So if the two events are actually dependent on each other, so definitely probability of A and B is actually equals to probability of B times probability of A slash B, or we can say probability of A intersection B is actually equals to probability of B times probability of A slash B, where probability of A slash B is known as conditional probability, that is probability that event A is going to be occurring given that event B has actually occurred. So let's go back to the question we have at the initial stage, which says that which of the following is an example of a dependent event. So the first question says watching the TV and eating. It is definitely possible for you to be watching the TV and also eating. The fact that you're watching the TV does not affect the fact that you're actually eating, or the fact that you're eating does not affect the fact that you're watching the TV. So definitely option A is out of it. So option B states that picking some balls from a bag with replacement. As we explained in the last few videos, when you perform your experiment with replacement, especially picking balls from a bag containing a larger number of balls, so you have an independent event. So option A is an independent event, option B is also an independent event. So those two options, the first two options, are actually out of it. So option C says that robbing a bank and going to jail. If you rob a bank, you will go to jail. For you to go to jail, you can actually rob a bank. So that means that if you don't rob a bank, you won't go to jail. So the events of robbing a bank and going to jail are actually two dependent event. So that means option C is actually a typical example of a dependent event. And the last option, which is option D, says that not paying your power bills on time and having your power cut off. If you don't pay your power bills on time, your power will be cut off. If you pay your power bills on time, your power won't be cut off. So that means these two events are actually dependent on each other. If you enjoyed this video, you know what to do. Please try to like this video and also subscribe to this YouTube channel. Thanks for making it to the end of this video, and we see you in the next one. Bye for now.